Hi everybody, in this video we are going over how to transform graphs, specifically the cotangent equation or cotangent function. It is going to be a crash course, so if you need more than that, please go to my graphing trig playlist, go to my page, go to the playlist and search. It's maybe one of the older playlists, so you might have to scroll down a bit, but it's probably like trigonometry is probably one of the first topics I started uploading onto YouTube, so I'm not sure how far down, but I have tons of videos on graphing trig. Actually, no, it shouldn't be that long ago. The good set of playlist videos for that might be from 2020 during COVID, the C word. Anyhow, let's go. I started filling this out already. Similar to tangent, we're going to look at the quadrantal angles as well as the angles exactly in the middle of each of those quadrants. Then we're going to evaluate cotangent at each of them. Cotangent is, in fact, the reciprocal of tangent. So if you know the tangent values at your quadrantals and at the middle of each quadrant, then it should not be a big deal to figure out the cotangent values, as it is just the reciprocal. I just smudged some ink down here. Sad. So let's highlight first to avoid this. So tan, the meditating man, if you know about him, that is telling us that tangent equals zeros on the sides. That means cotangent is going to be undefined in these locations, and then tan was undefined up here and down there, so cotangent is 0. Here tan was 1, but the reciprocal of 1 is still 1. Tan was -1, and the reciprocal of -1 is still -1. So there we go, easy peasy lemon squeezy. Now I'm going to take these values and put them on the graph. The symmetry for cotangent is odd. Just get that out of the way. It means if we rotate it 180 degrees, we get back the same picture. As for making the graph of cotangent, just grab this marker. We said it's undefined, so cotangent, 3 syllables, 3 asymptotes. So it's one here at 0, we've got another one at pi, another one at 2 pi. Number of syllables, number of asymptotes. Where does it equal 0? At pi over 2 and at 3 pi over 2. And then it's up first because it's positive. 1, -1 next quadrant, 1, -1. Try to draw your concavity correct. Concave up, arrow, arrow, concave down, also getting arrows. Done. Best thing you ever drew in your life. There you go. That is cotangent. That's all there is to it. Domain and range, I already did it on this graph, and this one's already entirely filled out. I'm not doing it again, so if you need to write it down, you can do that on your time. Domain is all real numbers such that theta does not equal, in this case, 0 plus, how far apart are they? Pi, n, comma, n is an element in the set of integers. Also, let's not forget, the period for, don't mind my seltzer, that's a pi. There's no 7 or anything. It looks a little messy. Pi over b, not 2 pi over b. It's 2 pi over b for the first 4, sine, cosine, cosecant, secant, tan and cotan, 1 pi. So tan, cotan, tan in the summertime, only enough room in the diet for 1 pi, not 2 pi's. And the range is from -infinity to infinity because it goes up and down, covering every y value, every output value forever and ever. The end. That, like I said, take the time you need to label what you got to label for yourself. That's an H, N, N, okay? Here I have negative cotangent. You can draw positive cotangent up here like I did for the other 5. I just need to save time. I need to go. I got to eat something. So negative cotangent I'm going to draw down here. So cotangent, we still have 3 asymptotes. First, middle, and last equals 0 in between. Now negative will go down first, but it looks like it's going up as a graph. Concave up looks like a cup. Concave up is shaped like that, and then concave down, concave down. So that is the negative cotangent graph. And now let's just finish this up. 12 is the k, that's right here. 5 is how much I need to add and subtract, so 17 and 7. Oh no, I'm getting a marker on my desk. A -11 pi over 6, leaving room if I need a common denominator. 2, so the period is pi over b, so quarter period is pi over, it's going to be 8, 1/4 of that. Again, I'm rushing. Figure it out. Watch the tangent video, watch the other ones, so make sure you know you're doing the right thing. Common denominator between 6 and 8 would be 24. So I'm going to multiply this on top and bottom by 3. quarter period is 3 pi over 24. Top and bottom by 4, negative 44 pi over 24. Adding 3, so the top is negative 41 pi over 24. 3 more, negative 38 pi over 24. Just following if you can't read my handwriting. Negative 35 pi over 24. 3 more, negative 32 pi over 24. 3 more, negative 29 pi over 24. 3 more, negative 26 pi over 24. 3 more, negative 23 pi over 24. Negative 20 pi over 24. Whew, there we go. Domain, all real numbers such that theta does not equal negative 44 pi over 24 plus the period is pi over 2n, comma, n is an element in the set of integers, range negative infinity to infinity. Thumbs up, thumbs down, comment, question, concern, put it in the comment section. Answer somebody else's questions if you are a genius and you could be helpful. Thank you so much. I will be back a little bit later with videos on rational functions, but I am taking a break for a few to go and eat something. If you need help with graphing rational functions, please, they're on my channel already, but I will do specific examples. I'm not going to do the ones if you know what packet I'm referring to over here. These already have videos. Every single one of these pages has videos. There's a video for this, all of them, okay? They're on the channel. There's a whole playlist. So the next pages, 1, 2, 3, 4, 5, 6, 7, 8. They already have videos, okay? So those have, the next 8 pages have videos. And then some, because I don't think I put the tan and cotan in here for some reason, but they have videos too. And then there's rational is the last thing I'm going to do. And then some mixed work. But yeah, food time. You know, I don't know what I'm saying. Bye.